When working with weight dependent questions, the first step we must always do is to multiply by the weight. So if, for example, we're given a liquid dose formula which is weight dependent, to find the first part of our formula, the what you want, we would multiply the dosage by the weight. The full formula is what you want over what you've got times the what it's in. Now the what you want really means what you want to give the patient, and the what you've got means what have you got in stock, or the stock strength, and the what it's in is the stock volume. So our formula could be expressed more simply as patient over stock times volume. But it's this formula we're going to apply for the 4 examples that follow, bearing in mind our weight dependent step that must be carried out first of all. Okay, we have 4 questions, each on the theme of liquid dose, and in each case we'll be using the same patient weighing 75 kilograms, and for parts A, B, C and D we'll each work out how many millilitres would we draw up. So for part A, the drug dosage is 1.6 milligrams per kilogram. So our first step is to multiply 1.6 milligrams by 75 to find out how much we give the patient. So let's call up our calculator, press clear. 1.6 times 75 equals 120. We're going to give the patient 120 milligrams. In addition, we are told that the drug is presented as a 2.4% solution. Now we know from a previous video that to turn this into milligrams per millilitres we simply multiply by 10. And multiplying any number by 10 is the same as moving the decimal one place to the right. So in this case we have 24 milligrams per milliliter, which is the same as saying 24 milligrams in 1 milliliter. So our liquid dose formula becomes what you want, which is 120 milligrams, over what you've got, which is 24 milligrams, times what it's in, times 1 milliliter. And we'll notice on our fraction part that both top and bottom have the same units, milligrams. So we can just get the calculator out straight away, no need to convert. Clear the decks. We have 120 divided by 24 times by 1, and our answer is just 5 millilitres. And we have our first answer. So on to part B. Part B has the same patient, but now we need to give 2.5 milligrams per kilogram. So as before, our first step is a multiplication. We'll multiply 2.5 milligrams by the 75. Let's pull up the calculator, clear the decks. 2.5 times 75 equals 187.5, equals 187.5 milligrams. Now we are told the drug stock is presented as 5 milligrams per 2 millilitres, which is the same as saying 5 milligrams in 2 millilitres. So we're now in a position to apply our formula, what you want, which is 187.5 milligrams, over what you've got in stock, which is 5 milligrams, times what it's in, which is in this case times 2 millilitres. Again, we notice that we're lucky and that the units on the both top and bottom of our fraction are the same. So again, no need to convert. We can just get the calculator out, clear the decks. 187.5 divided by 5 times 2, and the answer is equal to 75 millilitres. Equals 75 millilitres. And that's part B done. On to part C. The dosage we now need to give is 140 micrograms per kilogram. So our first step is to multiply 140 micrograms. I'm using MCG just as an abbreviation, but in a real exam you'd always write the answer as micrograms. So we have to multiply that by the same patient weight, 75. Pull up our calculator, clear the decks. 140 times 75 equals 10,500, in this case micrograms, equals 10,500 micrograms. Our drug is presented as 3 milligrams per milliliter, in other words 3 milligrams in 1 milliliter. Apply now liquid dose formula. We have 10,500 micrograms over what you've got, which is 3 milligrams, times what it's in, times 1 milliliter. And this time we see that our units top and bottom do not match. Micrograms on the top, milligrams on the bottom. We cannot proceed until we've converted one of them to make them both the same. I'm going to convert 10,500 micrograms into milligrams. Now that involves going up one step, and therefore I need to divide by 1000. If I pull up the calculator, it still has a 10,500 displayed, so I'm going to divide that by 1000, and that tells me that 10,500 micrograms is the same as 10.5 milligrams. So I can now rewrite this as 10.5 milligrams over 3 milligrams times 1 milliliter. My units are the same now, top and bottom, because I've arranged that to be so. So one more use of the calculator, clear the decks. 10.5 divide by 3 times 1 equals 3.5 milliliters. My final answer is 3.5 milliliters. Okay, on to the final question. Part B. The drug we're required to give is 70 micrograms per kilogram. So my first step, as in each case, is to multiply 70 micrograms times by 75. Pull up the calculator, clear the decks. 70 times 75 equals 5,250. Equals 5,250 micrograms. The drug is presented as a stock of 50 micrograms per mil. 50 micrograms in 1 mil. Apply our formula. We've got what you want, 5,250 micrograms over what you've got, 50 micrograms times what it's in, 1 milliliter. Now we're back to good old units of the same top and bottom. In this case they're both micrograms. Pull up the calculator, clear the decks. 5,250 divide by 50 times by 1 equals 105 milliliters. So our final answer is 105 milliliters. And I hope those 4 have given you examples of how liquid dose questions can be presented in an exam. For weight dependent dosage questions, you must always multiply by the weight first, but we also need to give consideration to the units. Do they match in the fraction, as well as looking out for other tripwires such as the dosage presented as a percentage solution. Thanks for listening.